Hey guys, it's PJ back with another lecture. We are going to discuss more sums about heights and distances. Moving on, I wanted to just remind you guys to hit share, hit subscribe, hit like on my videos. I know I'm new to the entire YouTube game, but I'm really trying to help you guys save a lot of time by picking up the characteristic sums and trying to give you a good understanding of the entire chapter with just a few sums, right? So also, if you are watching this video, I want you to check out the description. There might be a few tips in there or any links in there that might help you out. So check out the links and other content which I've given in the description. All right. So let's get started. Let's get started with today's lecture. We have 5 sums to solve. Let's look at the first example. Okay, the length of the shadow of a vertical tower on level ground, that means straight ground, increases by 10 meter when you change the altitude, when the altitude of the sun changes from 45 to 30. Calculate the height of the tower, corrected 2 decimal places. Now, how will we solve this sum? All right, how will we solve this sum? So first is making your diagram, step one. You always have to make your diagram. So obviously I'm going to draw my tower over here. This is my tower, right? This is my level ground. This is my level ground. Okay. So when the sun is somewhere here, the angle of the altitude angle is like 45 degrees. And then after some time, the position of the sun changes in the sky, right? So after a certain while, the sun position changes and you have your shadow coming all the way till here. So I'm just going to make the sun. The sun is here in case 1, okay? So in case 1, the sun was here, so you got the shadow till here. Let's call this point C, or let's call this point S1. And then in the next case, okay, the sun's altitude kind of changed. So you had the sun moving all the way till here, and then the angle sort of changed and you got a shadow all the way till here, S2. The length of the shadow increased. So this they are saying is 30 degrees, this they are saying is 45 degrees. Alright. And they've told us since the length of the shadow increased by 10 meter, the distance between these 2 points, S2 and S1, is 10 meter. What do we have to calculate? Calculate height of the tower. This is the tower. We have to calculate the height. Alright, so our diagram is pretty much ready. Let's just label it. This is O, A, S1, S2. Alright, not a big deal. Now, let's this what they have given us is OS2 minus OS1 is equal to 10 meter. So if we can express each of these in terms of height, in terms of age, if we express each of these in terms of age, we'll be able to solve an equation which will give us the height. So how will we get these how will we get these two lengths in terms of age? There's a simple way to do that. You will have to use trigonometry. So firstly, in triangle AOS1, tan 45. Tan 45 is nothing but opposite upon adjacent. Opposite to tan 45 in this triangle is height. So height upon OS1. So tan 45 is nothing but 1. So OS1 into 1 gives you h. So h is equal to OS1. This is our first piece of data that we have got. Next. Now in triangle OS2A, that's the bigger triangle, we will say tan 30 degrees is nothing but opposite. Opposite is again h upon adjacent. Adjacent this time will be OS2 because you're taking the bigger triangle. What do we get from this? Tan 30 is nothing but 1 upon root 3. So OS2 upon root 3 is equal to h. And this gives us, Okay, this gives us OS2 is equal to H root 3. This is our second important piece of information. Now, we can just plug in 1 and 2 into the original equation, into the starred equation. So, let's plug that in. We had OS2 minus OS1 is 10. OS2 is nothing but H root 3 minus OS1 is nothing but H is 10. H into root 3 minus 1 is equal to 10. H will be nothing but 10 upon root 3 minus 1. We can rationalize this by multiplying by root 3 plus 1 upon root 3 plus 1, basically the conjugate of the denominator. So 10 into root 3 plus 1, bottom में a plus b into a minus b is a square minus b square. So that will be 3 minus 1, which will give us 2. So answer is 5 into 1.732 plus 1. Root 3 is nothing but 1.732 into 2.732. Right? So just calculate this. This will give us 13.66. So our answer, that is height of tower, is equal to 13.66 meters. This is how you solve. For people who didn't understand, this is a minus b into a plus b. This gives you a square minus b square. Okay, and 1 point root 3 is equal to 1.732 for those who didn't know, and this becomes your answer. Right, let's go to the next one now. Yes, this speed distance time or uniform speed type sums are very important. They've solved it very in a very complicated manner in the textbook. They use X and all. I have a different approach to it. I just use something called unitary method. Why can we use unitary method? Because they've said it's uniform speed. Let's read the question. A man on top of a tower observes a car moving at uniform speed coming directly towards it. If it takes 12 minutes for angle of depression, notice there's an angle of depression to change from 30 to 45 degrees, how soon after this will the car reach the observation tower? First, we'll draw the tower. The tower is in red. Then I will draw my ground over here. Alright. Now, see, first, let's draw an imaginary dotted line because this is angle of depression. Imaginary dotted line of the horizontal. They have said it takes 12 minutes for the angle of depression to change from 30 degrees to 45. So in the first case, 30 degrees was somewhere here, like this. And how did it look? Angle of depression, that's why it was 30 degrees. And then it changed to 45 degrees when the car reached over here. This is 45 degrees. 45 degrees. Please don't measure it. I've done it with my free hand. Alright. So if you use properties of parallel lines, this 30 degrees and this is interior alternate angles. Same for 45 interior alternate angles. Now let's just name it O, A, B, and let's call this T because the man was over here on top of the tower. Top tower. They've said whatever car was there over here, no, there was some car over here. In 12 minutes, he came from B to A in 12 minutes. So I'll tell you my strategy of what I'm solving. Okay. They've asked us how soon after this will the car reach the observation tower. So means they are saying to go from A to 0, how much time will it take? They are asking us this. Right. So what I will do first, first I will calculate AB, distance AB. Then I will say if AB took 12 minutes, then how much time does AO take? This will be the unitary method part of our sum. So this is my general strategy. Now, in order to find AB, we will have to use our trigonometry. Okay, so this is how we will do it. First, AB is nothing but OB minus OA. So, firstly, in triangle TOA, tan 45 degrees is nothing but opposite. I'll call this height of the tower H. Have they given us the height of the tower? No, they haven't. So let's just call it H. Height of the tower, that's opposite upon adjacent OA. So OA is equal to H. This is our first equation. In triangle TOB, we get tan 30 degrees is equal to opposite upon adjacent OB. So we get OB is equal to H into root 3 because tan 30 is nothing but 1 by root 3. Root 3 shift on other side becomes multiplication. This is our number 2. Now what do you have to do? Plug 1 and 2 into this starred equation. Simple. AB is equal to H root 3 minus H. Take H common. H into root 3 minus 1. Alright. Now we will use our unitary method. Now see how unitary method. We will do unitary method with two quantities, distance and time. Now to cover distance AB equal to H into root 3 minus 1, it took the car 12 minutes. Now to cover distance OA, they're asking us to cover distance AO is equal to H, how much time? So obviously now remember, calculate this. Root 3 minus 1 is nothing but 1.732 minus 1, which is 0.732. So who is bigger, 0.732 H or H? Obviously H is bigger. So for a less distance it takes 12 minutes. For more distance it will take more time. Therefore, for unitary method, the question mark, or let's call it x, okay? Let's call this the random variable x, will take more upon less, that's 0.732h into 12, which is 12 divided by, you can say 0.732, or 12 divided by root 3 minus 1, rationalize, you will get 12 into 2.732 divided by 2. So your answer is x is equal to 6 into 2.732, and this gives us 16.39 minutes. This is your answer. Very, very cool sum. Always solve using this approach where we use unitary method. Unitary method. But remember, we can use unitary method only because it's uniform speed. Right? If it was accelerating speed, you can't use unitary method because the speed is continuously increasing. Next. An aeroplane flying horizontally 1 km above the ground and going away from the observer. We have, yeah, 3 sums left. An aeroplane flying horizontally 1 km above the ground, going away from observer, observed at elevation of 60. After 10 seconds, it's observed to be 30 degrees. Find uniform speed, okay? Remember, speed ka formula is what? Speed is equal to distance upon time. Time though they have given us, 10 seconds. So our job is to basically find this distance. Now, how to find the distance? For that, you'll have to draw one diagram. So an aeroplane is flying horizontally 1 km above the ground going away from observer. First, I'll mark my observer always. Let's mark my observer over here. So first let's say the aeroplane was here at this point A. Then after 10 seconds, it was observed at this point B. Now let's just connect all the lines. They've said he was going in a horizontal path, the aeroplane. Make the ground, connect this straight down, connect this straight down. Okay. Look at how I'm marking my angles. At initial point A, the angle of elevation was 60 degrees. At after 10 seconds, 10 seconds, it reached B where the angle was 30 degrees. So technically, you know what we have to do? We have to find this distance AB because we have the time for that amount of distance. So we need to find this distance AB. Let's call this OAB. Let's call this point C. Call this point D. And they've told us that it is flying 1 km above the ground. Let's keep this as 1 only, 1 km, because they want answer in kilometer per hour. Alright. Next. Now it's very easy to solve the sum. We just have to use some basic trigonometry. In triangle AOC, alright, let's do tan 60 degrees. Tan 60 degrees is nothing but AC upon OC. AC is 1 upon OC. So tan 60 degrees is OC root 3 is equal to 1, or OC 1 upon is equal to 1 upon root 3. What is the unit? km. Okay. Remember, tan 60 degrees is root 3. Next, in triangle BOD, tan 30 degrees is obviously opposite upon adjacent OD. 1 kilometer upon OD. If we further solve this, OD is equal to root 3 km because tan 30 is equal to 1 upon root 3. So when you shift it on the other side of the equation, you will get root 3. Now, won't look at our diagram. Look at our diagram. ABCD is a rectangle. So won't AB is equal to CD? Okay, so basically if we find CD, if we find this distance, it's the same as AB. Now how will we find CD? CD ka finding is simple. CD is equal to nothing but the big part OD minus the chotu part OC. Look at the diagram for this. OD big minus OC will give us CD. Alright. So CD is equal to OD, that's root 3 minus OC. What is OC? 1 upon root 3, and this will be in km. Let's take LCM. You'll get 3 minus 1 upon root 3, which is 2 upon root 3. If you rationalize this, you'll get 2 root 3 upon 3 km. That is our CD. Now the time given T is 10 seconds. We need to convert seconds into hours. So divide by 3600. So you will get 1 upon 360 hour. Why divide by 360? Because 1 hour is equal to 60 minutes into 60 seconds. That is 3600 seconds. Alright. Now the sum becomes relatively simple. They've asked us to find the speed. So we have number 1, we have distance d, and we have time in hour. So speed in kilometer per hour, as they've asked us, will be distance upon time. That is 2 root 3 upon 3 whole upon 1 upon 360. Denominator ka reciprocal happens. You get into 360. This will give you 240 root 3 km per hour. Once we calculate this, you get the plane traveling at 415.69 kilometer per hour. This is your final answer. Speed of the aeroplane. Next sum. Yes, this is a tricky sum, number 8, because here you will realize how important a diagram is. Okay, how important a diagram is to your solution. So, in order to do this, let's first read the question. Angle of elevation of a stationary cloud means it's not moving at a point 25 meters above, from a point 25 meters above a lake is 30 degrees. An angle of depression of its reflection in the lake is 60 degrees. What is the height of the cloud above that lake level? In this, a concept of physics is also used. Physics concept is used, is that, uh, okay, image distance is equal to object distance. I'll explain this shortly after I draw the diagram. First, understand the diagram. I will draw, let's say in blue color, first I'll draw my lake surface. This blue color line is my lake surface. Let's call it LS, lake surface. Alright. The angle of elevation of a stationary cloud from a point 25 meter above the lake. Let's go 25 meters above a lake. Call this is where we are observing from. So O. And so this is 25 meters. Okay. And we are observing some cloud over here. Let's call the cloud C. Now I'll switch colors, make it normal black. Always draw a horizontal line from the observer so you know with what your reference is. They've said this angle of elevation is 30 degrees. Now, imagine that this lake surface is like a mirror, okay? Like a mirror. Think of the lake surface like a mirror. I'm just joining the lines so that I get my triangles. Okay, just joining the lines. The lake surface is like a mirror. They want to find what is the height of the cloud above the lake level. Never mind. So this is your object distance. And if the lake acts like a mirror, the cloud will form some image. The cloud will form some image on the surface of the lake. So let's look at that image. Sorry. Let's look at that image. It will be a straight line down here. Right? And they've said that the angle of depression of its reflection in the lake is 60 degrees. The angle of depression is 60 degrees. Now let's go ahead and name everything. Let's go ahead and name everything. I'll call this A, I'll call this B, O and all is the name only. Remember, we have to find this object distance, and this is the image distance. Okay. Now because this is 25, even this part will be 25, this much. Let's call this remaining part, x. So then this whole part, image distance will be x plus 25. Why? Because object distance. Why? Because at the start I've told you guys, object distance is equal to image distance. Very important point over here. Alright, now your diagram is ready. Now all we have to do is apply some simple trigonometry and we'll get our answers. Okay, so firstly, in triangle OAB, tan 60 degrees is opposite. Remember, look at the triangle OAB, opposite, that is whole AB upon adjacent, that is OA. Okay, so OA is equal to AB divided by tan 60. Now, what is the value of AB, guys? What is the value of AB? AB is nothing but 25 plus x plus 25. Look at the diagram. Upon tan 60 is root 3. So this we get as x plus 50 upon root 3. Leave it here. Leave it here. It will be whatever meters. Okay, leave it here. Next, let's look at the other triangle that is formed, OAC. In triangle OAC, we get tan 30 degrees is equal to OAC. Tan 30 degrees is equal to AC upon OA, which is equal to x upon OA. So tan 30 is 1 upon root 3. So OA is equal to x root 3 meters. Now all you have to do is equate this 1 and 2. Why? Because we are talking about the same guy. We are talking about OA in both. So equating 1 and 2. What do we get? We get x plus 50 root by root 3 is equal to x root 3. Shift root 3 on the other side, root 3 into root 3 becomes 3. So we get x plus 50 is equal to 3x. You get 2x is equal to 50 and you get x is 25 meter. But your sum is not over here. They have asked us to find what? The height of cloud above lake level. So we need to find this distance. You see my dotted line? SC. We need to find SC. SC is nothing but answer. So SC is nothing but x plus 25. So we will get 50 meters. And this is our answer. I hope you loved this sum. Please don't make a mistake in the diagram. Always take everything with respect to your observer. This is the angle of depression. This is the angle of elevation. Take it with respect to your observer, who is 25 meters above the lake level. Next sum. This was a sum that was in ICSE. Okay. This was a sum given in ICSE. From the top of the lighthouse, 100 meters high, the angles of depression of two ships are observed to be 48 and 36 respectively. Right? Find the distance between the two ships and the nearest meter. Firstly, let's make our lighthouse 100 meters high. I'm not going to make it 100 meters, don't worry. Yeah, this is our lighthouse. Let's call this OL. L for lighthouse, so OL. It is 100 meters high. The height of the lighthouse is 100 meters. Angles of depressions of two ships are observed 48 and 36. Find distance between the two ships if the ships are on the same side and the ships are on opposite side. So let's do part 1 first on the same side. Okay. So part 1. The first ship, first so we'll make our horizontal because the observer is standing at the top of the lighthouse. First ship is at some distance, let's say 48 here, and the next ship is somewhere over here at 36. They've told us there are angles of depression. So in your diagram, make sure you mark it up top over here. The smaller angle is 36 degrees and the bigger angle is 48 degrees. Let's name this, A and B. They are asking us to find the distance AB in part 1. Okay, because they're asking us find the distance between the two ships to the nearest meter. Now it's very simple. Direct sum solving in triangle LOA, we get tan 48 degrees is OL upon OA. OA is equal to OL is how much? 100, because that's the lighthouse ka length, upon tan 48. You have to calculate the value of tan 48 from your logbook in case such a sum comes. In my case, I will just use the calculator. You will get this at around 90.04 meters. Okay, and in triangle LOB, tan 36 degrees is opposite, that's OL upon adjacent OB. OB becomes 100 upon tan 36. Again, calculate tan 36 from logbook. This answer around 137.64 meters. Now, obviously, for part 1, the distance they want is AB is equal to OB minus OA. So for the second part, it's very simple. For the second part, the distance between them will be nothing but OA plus OB. Alright guys, I hope this lecture was pretty fruitful to you. Please pay attention to these sums. Try to solve them on your own, okay? You can solve some more sums from your textbook for practice. But these are some types which I felt were really good sums. So I hope you liked the lecture guys. Please hit like and subscribe if it helped you. I'll see you in my next lecture. Best of luck for your tests and exams. Bye-bye.